everyone, it's Alyssa and welcome to You Can Learn Math. So today we're talking about angles formed outside of circles by two intersecting lines. This is not, just before we get started, this is not if you have an angle like this, a central angle when it's in the middle. It is not for inscribed angles where they're on the side, where the point is, the vertex is on the side of the circle. It is not for intersecting chords inside the circle. And it is not for, this is probably the one most likely get here by accident, for a tangent plus a chord where it is crossing the circle and it's kind of contained and the angle is right here on the circle, as it were. None of those are in this video. Those are all separate concepts. I do have links to videos explaining them in the description below. This video is very specifically, the vertex of that angle is not on the circle. It's not in the circle or on the circle. It is outside. This is formed by three different methods. We can have a tangent. A tangent is a line that touches a circle at just one point, like boop, right there. Could be a tangent and a secant. A secant is a line, it looks like it's a chord that keeps on going. Strikes out, boldly goes where no chord has gone before and goes beyond the circle. That is a secant. So this would be a tangent and a secant. It could also be a tangent and another tangent. We have two tangents. Or it could be a secant and another secant. In all three cases, as you'll see here, the point, the vertex of this angle is outside of the circle, not on it or in it. That is key. Now, all three of these look very similar to each other, so fortunately you don't have to remember three different formulas. They all have the same formula. And I'm going to type this over here so that you can see it. There we go. Here's our text. This is how you're likely to see it written in your math books. It says an angle formed, let's move this a little bit so you can see it. There we go. An angle formed outside of the circle formed outside of the circle by two tangents, a tangent and a secant, or two secants, is equal to half the difference of the intercepted arcs. All right, so that's the text you're going to see. Let's put this into practice. Let's actually look at some examples. I don't know why it's not wanting me. There we go, to move things. Let's look at some examples and write this in formula form so we can really see what's going on. So first I'm going to start with two tangents. So let's say I have a tangent there, and then I'm going to have a tangent there. So I have two tangents. And it tells us this angle that's formed here is equal to half the difference of the intercepted arcs. That phrase intercepted arcs, this comes up constantly when we are talking about angles inside, outside, and all around circles. So the intercepted arcs, we're talking about where the little legs of our angle touch the circle and the arcs that it divides the circle into. So the intercepted arcs here, we would start at this point of tangency and go all the way around. And the other intercepted arc would start and go the other way, all the way around. Those are the two, don't do that, the two intercepted, let's turn that off, intercepted arcs. So in this case, I'm going to say this is A, this is B, and this point is C. So now I can write this in a very specific little format here. Oh, I'm going to need a little point out here too, call it D. Okay, so this angle, the angle formed outside of the circle, is angle ABC. So this little m means measure of. So measure of the angle ABC is equal to half the difference. Difference means subtract. We don't use this term difference that often. Sum for adding is probably more common. You probably may have had more exposure to that, but difference does mean subtracting. So the difference of the intercepted arcs, you're always going to put the bigger arc first so that you have a positive result. We can't have a negative degree measure. That's just not possible. We can't do that. It's going to be positive. So in this case, if I was told that, actually let's move this, let's give you a little more room here. There we go. Okay, so half the difference of the intercepted arcs. Gives a little more space. So the first intercepted arc is that big major arc that goes from A to D to C. So we would write that as the measure of arc ADC. And then we have the smaller one that goes the other side from A to C. So minus the measure of arc AC. And that would be a formula way of writing this, transferring this text into a formula. So let's put some numbers in here. All right, so let's say I'm told that ADC, this arc ADC, is, I don't know, 220 degrees, and that arc AC is 140 degrees. These will always add up to 360 if we're talking about the entire circle. An entire circle is 360 degrees. So if I were to plug those numbers in, measure of arc ADC is 220 degrees. Measure of arc AC is 140 degrees. I want to multiply that times a half. 220 minus 40 is 80. And if I multiply that times a half, that equals 40. So my angle here, ABC, is 40 degrees. If I have, actually I'm going to, I cannot talk today, doo-da, doo-da. All right, let's get rid of these and let's go and let's do a slightly different one. Let's show our next one here of a tangent and a secant. So we're going to have that same point. I'm going to start that same little point over there. If I can draw properly. Apparently I can't. We'll do it like that. We'll make it work. So I have a tangent and then I have a secant. Here we're going to do the same math. The key though is we want to make sure we are identifying the intercepted arcs correctly. So when we have a tangent and a secant, if I call this A, B, and C, and this little point is going to change now. This point right here is going to be point D. Call that. Right, so the intercepted arcs here go from A to D, and on the other side from A to C. This other arc that's out here from D to C is not a part of this. We're not going to be using the whole circle when it's just a tangent and a secant. There will be a part that is excluded. So AD, arc AD is the larger arc, AC is the smaller, so we're going to be subtracting AC from AD in the same exact process that we did before. Whatever AD was, let's say that was 110. If AC was 90, I'm going to take the difference of those and multiply by a half to get my angle. 110 minus 90 is 20. A half times 20 is 10. This angle then would be 10 degrees. Same process if we have two secants. Same thing. I'm going to draw that just so you're very clear on what those intercepted arcs are going to be. So if I have two secants that are coming across like this, in this case my intercepted arcs would be from here to here. That's the larger one. And then the smaller one is from here to here. Same thing. I subtract the smaller from the larger, multiply by a half. You can also say divide by 2, and that will give you this outside angle. Now that's very straightforward. They are going to throw some tricky things in there because of course they are. It's a given. They're going to throw algebra. It's going to happen. Another thing they're going to do sometimes is they might give you arcs that are outside, that are not the intercepted arcs, and then try to make you solve for those intercepted arcs and go from there. That's very, very common. So I have some sample questions. So here's one. This is a more straightforward one. Let's say if they gave you, and they said this was 50, and this out here was 40. What is this one? This isn't too complicated of an algebra problem, but there is still, we're solving for x. It is an algebraic problem. We're just going to set up the equation based on what we know. We know that for 2 secants, and they have an angle outside, it is half the difference. We have the bigger arc out here, that is x. We're going to subtract the smaller arc here, that is 50, and it's going to be half of that is equal to that outside angle. In this case, that's 40 degrees. I could distribute this 1/2 throughout and then solve, but I think I'm going to get rid of the 1/2 instead. Both ways work. It doesn't matter which way you do. This is just a personal preference. I'm going to multiply both sides by 2 to get rid of that 1/2. On the left side, I have 2 times 40, or 80. On the right, the 2 and the 1/2 cancel out, and I have x minus 50. To solve for x, I need to do the opposite of subtracting 50. I need to add 50. And I would get 130 equals x. This kind of thing is pretty common where they plug in x for one of those 3 spots in the equation and ask you to solve for it. They also may do something a little more tricksy. Here was one that I found online. I think this was off, is it Kuda products worksheets that they have, their free worksheets they have available. I think that's where I found this particular problem to give them their credit. Okay, so here we have 2 secants, and they have this outside as being 4x plus 50, this inside here as being 30, and this little outside angle as being 3x. Don't let it throw you, just do the same process. So our process is that we know the outside angle is equal to 1/2 the big intercepted arc minus the smaller intercepted arc. Same thing here. I'm going to get rid of that 1/2 instead of distributing. So I'm going to multiply by 2 on both sides. On the left, I get 2 times 3x, or 6x. The 1/2 and the 2 cancel out, and I'm left with 4x plus 50 minus 30. And there's nothing really strange going on here with, there's not anything besides the 30 inside those parentheses. So I can get rid of these parentheses in this case and then just combine like terms. 50 minus 30, and I'm still erasing. Shouldn't be doing that. There we go. 50 minus 30 is 20. So I have 4x plus 20 equals 6x. I'm going to subtract 4x on both sides to get all the x's on one side and numbers on the other. So on the left, I have 2x, and on the right, I have 20. I divide both sides by 2. I keep zooming out. I divide both sides by 2, and I get that x equals 10. In these kind of problems, I always like to remind students that it is very important at this point when you have these types of problems where they're having x and they have arcs and they have angles to go back and look at the problem you're presented with and make sure you know what they are asking for. If they are asking for x, your answer is 10 and you're done. If they are asking for one of these angles, you need to plug it back in, or these arcs. So here, to plug it back in, 3 times 10, our x, is 30. Here, 4x plus 50, 4 times 10 is 40, plus 50 is 90. So if they're asking for x, you have your answer. It's 10. If they're asking you for this angle out here, you have your answer. It's 30. If they ask for this arc out here, you have your answer. It's 90. If they ask for all of them, you got that too. Just be super careful with that. But these are definitely the types of problems they will give you. They just absolutely love throwing algebra back in there with your geometry problems. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.